This is a video on integration using the method called partial fractions. So consider this integration problem. So there's no formula to directly integrate this. You might be tempted to try integration by substitution, but what you'll find, if you let u equal to the thing on the bottom, you'll find that du dx will be 2x minus 6. Now that's not any multiple of the thing on top, so you're not going to be able to get rid of all your x's when you make the substitution. So we need something else for this problem. What we're going to do instead is break up this fraction into the sum of two fractions, and we should then be able to integrate each of those two. Our first step will be to factorize the quadratic underneath the line. So it's going to be x plus something times x plus something else. In this case, we have minus 6 and 8. So 4 times 2 is 8, and minus 4 minus 2 is minus 6. So minus 4 and minus 2 will be our factors here. Next, I'm going to say that's equal to something we'll call a over x minus 4 plus something else we'll call b over x minus 2. And now we have to figure out what a and b must be in order to make this equation true. So if I add up that thing on the right, what I get is a times x minus 2 plus b times x minus 4 over x minus 4 times x minus 2. So I've added up there with a common denominator, and that common denominator is the denominator that we started with on the left. So if these two things are equal, then the numerators must be equal because the denominators are, and so a times x minus 2 plus b times x minus 4 must be equal to that numerator on the left, 8x minus 28. Now, we're assuming that a and b are just numbers. They don't have any x's in them, they're constant. So what we can do is compare the powers of x on both sides of this equation. So on the left I have ax and I have bx. So I know that a plus b must be equal to 8 because I have 8x on the right side. And I have a times minus 2 and b times minus 4 on the left. So minus 2 times a minus 4 times b must be equal to minus 28. So I've compared the x terms on the left with the x term on the right, and the constant terms on the left with the constant term on the right. And now I have two simultaneous equations in a and b. You can solve these any way you like to get a and b. What I will do is add twice the first equation to the second to get rid of those a's. So 2a minus 2a would be 0. Minus 4b plus 2b would be minus 2b. And minus 28 plus 8 would be minus 20. So minus 2b is minus 20. So that implies that b will be equal to 20 over 2 is equal to 10. Now that I have b, I can substitute that back into my first equation to get a. So a plus b is equal to 8, so a plus 10 is equal to 8. So that implies that a is equal to 8 minus 10 is equal to minus 2. So I have successfully found a and b, and now I can rewrite my original fraction. So there it is, with my a and b put in, and this is something that we can integrate. So on the left, I have the integral of minus 2 over x minus 4. So that minus 2 will stay in front. Now we have to integrate 1 over x minus 4 with respect to x. So the integral of 1 over x is the log of the absolute value of x. And the integral of x minus 4 is the log of the absolute value of x minus 4. You could do this with a substitution in for x minus 4, but the derivative is 1. And so that's why you don't get any extra factor in front or anything there. And I integrate 10 over x minus 2, and I get plus 10 times the log absolute value x minus 2, and plus c at the end for the indefinite integral. So that is integration with the method of partial fractions. When you factorize your denominator, you may not get x plus something and x plus something else. You might get something more complicated, and in that case you'll have to split up your partial fractions differently. So what we just had was two linear factors. So for example, if I had something like 2x plus 8 over x plus 1 times x plus 3, then I would split this up like we just did. A over x plus 1 plus b over x plus 3. Now, if we had something else, let's say we had 6x squared plus 2x plus 3 on top, and on the bottom we have some repeated factor. So let's say we had x plus 2 squared on the bottom there. In that case, you would have to account for that repeating factor, and you would do it like this. You would say that's equal to a over x plus 1 plus b over x plus 2, and then to account for the repeating factor you'll have another term, c over x plus 2 squared. Finally, on the bottom you may not be able to reduce the quadratic. So if you have an irreducible quadratic like this one, where I can't factorize that anymore, but writing a over x plus 2 and b over x squared plus 3 won't quite work. What you'll have to do is this. You'll have to say that's equal to a over x plus 1 as before, and you'll have to write something over x squared plus 3. But in this case you'll have to have an x term in here. So you'll have to write b times x plus c and work from there. So that is the way to break down each kind of denominator that you might encounter. We've done an example of the first type, so I'll now do an example for the second and third types. Let's try this one. 18x plus 6 over x minus 1 times x plus 1 squared. So this is a repeated factor in your denominator. The way to break up this function is to write a over x minus 1 plus b over x plus 1, and to account for the repeated factor c over x plus 1 to be squared. So when I add up that fraction on the right, I'm going to have a times x plus 1 to be squared plus b times x minus 1 times x plus 1 plus c times x minus 1 over x minus 1 times x plus 1 to be squared. So where did I get these terms next to a, b and c? Well, I'm just doing adding fractions with a common denominator. So for that a term, to get the common denominator x minus 1 times x plus 1 to be squared, I'd multiply top and bottom by x plus 1 to be squared, and similar for b and c. So now I need to look at this term by term. So I'll have to multiply out that top line there. So 18x plus 6 is equal to a times x squared plus 2x plus 1 plus b times x squared minus 1 plus c times x minus 1. So that's the equation saying that the numerator of those two fractions must be the same. Now I can compare the terms. So I have no x squared term on the left. So that means that a plus b must be equal to 0, because I have ax squared and bx squared. Next I compare the x terms. Well, I have a 2x in the a bracket, and I have an x in the c bracket, and I have no x term in the b bracket. So that 2x there gives me a 2a, and that x in the c bracket gives me a c, and the x term on the left is 18x. So 2a plus c equals 18. And finally the constant terms. Well, I have a 6 on the left, I have a 1 with the a, I have a -1 with the b, and a -1 with the c. So a minus b minus c must be equal to 6. Now I have 3 equations and 3 variables. Now you can solve this any way you like. What I will do is, if I call these equations 1, 2 and 3, I'm going to take away twice the first equation from the second and 1 times the first equation from the third. So I'm going to have equation 2 minus 2 times the first one, and equation 3 minus equation 1. And that's going to eliminate a from equations 2 and 3. So if I take twice a away from a, I get my 0. And if I take away twice b from c, I get c minus 2b. And if I take away 0 from 18, that's still 18. So there's one equation in b and c. And if I take away the first equation from the third equation, I kill my a's. I have minus b minus another b. That c is still there. And again, there's a 0, so that's still just 6. Again, you can solve these 3 equations any way you like. This is the way I'm doing it. Now I have 2 equations in b and c. So I will just add these 2 equations together. So the c's cancel. I get minus 4b is equal to 24. So that gives me that b is equal to minus 24 over 4 is equal to minus 6. So now that I have b, I can go back and get c. So if I go back to, say, this equation and pop in my value for b, I will get c minus 2 times minus 6 is equal to 18. So that means that c plus 12 is 18. So c will turn out to be equal to 6. And finally, I want a. So to get a, I'll go back to my first equation. A plus b is equal to 0. So that means that a minus 6 is equal to 0. So a must also be equal to 6. Now I can go back and do my original integral. So that original integral is equal to the integral of a over x minus 1, which we now know is 6 over x minus 1, plus b over x plus 1, which we now know to be minus 6 over x plus 1, plus c over x plus 1 to be squared, and we know c is 6. So now I can integrate this. So the integral of 6 over x minus 1 is equal to, now you could do substitution here, but it's not really necessary when you just have x plus something, because du dx will be just equal to 1. So what we'll get is 6 times the log of the absolute value of x minus 1. So the integral of 1 over x is log absolute value of x. Same thing for the second term. I have that minus 6 in front, times the log absolute value of x plus 1. And for that last term, I'll have that plus 6 in front. And what we have there is x plus 1 to the power of minus 2. So again, you could substitute u in for x plus 1, but since it's just x plus something, we don't really have to do that. The integral of x to the power of minus 2 would be minus 1 times x to the power of minus 1, or minus 1 over x in this case, or x plus 1 that we have here. And finally plus c, constant of integration. So my final answer would be 6 times the log of x minus 1 minus 6 times the log of x plus 1 minus 6 over x plus 1 plus c. So there's an example with repeated factors in the denominator. I'll do an example of the last type where you have an irreducible quadratic in the denominator in the next video.